Today, we are focusing on the setting up of free body diagrams. Okay, so get strapped in. So we're going to determine the total force acting on an object is equal to 0 or not, and write a mathematical expression describing the forces of motion of an object. So everybody get out something to draw on, to practice. Draw the free body diagram of that box. Free body diagram of that box. How to do? Not too bad. Okay. That is step 1 of 5. Step 1 of 5. The most important step. If you mess this up, you're hosed. Like, this is foundational. Okay? That's why I emphasize so strongly getting this free body diagram right. Okay? So, step 2 is pick which way you want to be the positive direction. So I've listed all these steps in the next couple slides. So you're welcome to pay attention, write them down, not write them down. I have them listed. They're on the PowerPoints, ready to go. But I'm going to talk you through those 5 steps. Okay. So pick the way you want to be positive. My strong recommendation is make the way it's moving positive. Okay, make the way it's moving positive. Even if it's moving down, make down the positive direction. Okay, so I'm going to make to the right the positive X direction, and up because we don't, it's not moving in the Y direction, so just it's more natural for us to pick up to be positive. So that symbol there defines which way is the positive direction, to the right and up for this problem. Okay, that was step 2. Step 3. This one's really important as well. Remember in projectile motion how we had the horizontal and vertical chart? We separated out how's it moving in the horizontal direction, how's it moving in the vertical. We're going to have a similar idea, and we're going to look at the sum of the forces in the X direction, and we're asking ourselves, is that equal to 0? And the sum of the forces in the Y direction, we're asking ourselves, is that equal to 0? Okay. So to determine if the sum of the forces are equal to 0 or not, we're going to look at the motion, not the free body diagram. Okay. So the first question is the sum of the forces in the x direction, is that equal to 0? I want you to think. Tell your neighbor why or why not. Is the sum of the forces in the x direction equal to 0? Okay, what do you say? Yes or no? Sum of the forces in the x direction, are they equal to 0? No, why not? Okay, it is speeding up. Is inertia in the x direction doing what it wants to do? No. Is inertia happy in the x direction? No. Therefore, the sum of the forces are not equal to 0. So we say not equal to 0. Okay. Is the sum of the forces in the y direction equal to 0? Just think. Tell your neighbor why or why not. Okay. In the y direction, is the sum of the forces equal to 0? Yes. Why? It's at rest. Okay. Is inertia doing what it wants to do in the y direction? Yes. Is inertia happy? Yes. So it is equal to 0. That is step 3. Okay. Step 4. We are finding the sum of the forces, meaning we are adding the forces together in the x direction. Okay. So what forces are acting just in the x direction? Friction and applied force. Okay. Now we're going to add those together, friction and applied force, but we're going to keep an account which of those is positive and which of those is negative. Okay. So you said friction. Is friction acting in the positive or negative direction? Negative. Okay, I don't expect you to write it this way. I'm just being very explicit with my teaching right now. Okay, so you have a negative friction plus applied force. Is that going in the positive or negative direction? Positive. Plus a positive applied force. Okay, mathematically, what would be a simpler way to write this? Yep. Applied force minus friction. I would expect you to write it this way. You can write it this way if you want. You could say negative friction plus applied force. That would be fine too. Okay. But more of you are going to choose to write it this way. Okay. Good with that? So we're adding up the forces in the x direction. I want you to do the same thing for the y direction. How'd you do? Good? That was step 4. Last step. Oh, that was premature. Okay, so we added up our forces, and then we need to say, what is it equal to? Okay, in the y direction, it's pretty straightforward. I actually showed it to you already. You're adding those together, and they equal 0. Why? Because we already established that right here. Okay, so what this means is when you add normal force and force of gravity, they cancel each other out. They equal 0. The sum of the forces in the y direction are equal to 0. Good with that? In the x direction, they're not equal to 0. Like, so what are they equal to? Like, I don't know. Well, that's not helpful. But we know algebra. And we know we don't necessarily even need to know a number. We can just put a variable in there. Okay? That's equal to some total force, some net force. I don't know what it is, but it's equal to something that's not 0. It's the total of these. Okay? Now, how is that helpful? Because we know Newton's second law is true. The net force is equal to mass times acceleration. Okay with that? So what we can do here is take that quantity, mass times acceleration, and we can substitute in for net force or total force. So your setup, if it's not equal to 0, you set it up equal to mass times acceleration. In this case, it's in the x direction. That's what I want you to write. Okay? It's equal, not to 0, but it's equal to something. I don't know what it is. So we write a variable, the total force. But we know that the total force is equal to mass times acceleration, so we can just substitute that in there. Okay? Folks, if you can own these 5 steps, you can do any force problem that I throw at you. Okay? This is a super easy example. It's going to get way more complicated. But if you can own these 5 steps, if you can embrace them and not do shortcuts, you'll master these things. They are yours for the taking. Okay? Good with that? Okay. And this is what I want you to do for your homework. Day 2 on the setup. Free body diagram worksheet. You've done step 1. I want you to do steps 2, 3, and 4, and 5. Okay? Any questions before I move on from here? Any points of confusion? Usually, here's the popular question tomorrow. Mr. Smiley, how did you know to minus friction? Great question. It's because friction was going in the negative direction, and we're adding a negative friction to that. That's why it's subtracting. Applied force is going in the positive direction, friction is going in the negative direction. Okay? If you still have that question tomorrow, that's totally fine, but that's a very popular question as you're going over to that. Okay? All right, so this is how to bake a force problem. The instructions, again, you'll have those. You can pause the video if you're listening to the video, but I just talked you through that one. That's steps 1 through 3, and then 4 through 5. Okay, just talked you through it all. All right. Step 1, free body diagram of the box. Go. How do we do? I just drew the arrow really big because I'm going to do stuff with it. Just for your visual viewing, I don't know, advantage. We'll say that. Okay. Good there? Okay, it's tension because we're being pulled by a rope, not by your arm. Okay. Step 1. Step 2, pick the positive direction. Pick which way you want to do the positive direction, both in the X direction and the Y direction. The strong recommendation is make the way it's moving positive. So I'm going to make to the left positive and up positive. Do that. Step 3, determining is the sum of the forces in the X direction equal to 0 and the sum of the forces in the Y direction, are those equal to 0? Okay, the sum of the forces in the X direction. Is it possible for an object to be moving and the sum of the forces are equal to 0? Is it possible for the sum of the forces to be equal and an object to be moving? Is it possible for an object to be moving and the sum of the forces equal to 0? Tell your neighbor why or why not.
So, yeah. Yeah.
Is it possible for the sum of the forces to be equal to 0 and the object be moving? Yes. How do you describe the motion? Constant velocity. Okay. If inertia is doing what it wants to do, an object at rest will stay at rest, and an object in motion will stay in motion. Oh. Okay. If it's doing what it wants to do, if the inertia is like, yes, I'm moving and I'm continuing to move, then you know that the sum of the forces in the x direction are equal to 0. How are we doing with that? We don't have a problem with an object at rest wants to stay at rest. Sum of the forces are equal to 0. That's easy for us. That makes sense. But when we get to things that are moving, like, well, it's moving. Probably not. Nope, nope, nope. Can't be moving. I mean, it's moving. An object in motion wants to stay in motion at a constant velocity. So if the problem says you're moving at a constant velocity, you're moving at a constant speed in a straight line path, then you know in that direction the sum of the forces are equal to 0. You all right with that? Okay. So in the y direction, the sum of the forces is equal to 0. Thumbs up, thumbs down. In the y direction, okay, it's not moving in the y direction, it's at rest in the y direction, so some of the forces are equal to 0. Okay, that was step 3. Step 4, we add up the forces in the x direction, and we add up the forces in the y direction. So before we dive too deep, is tension acting purely in the x direction? Is tension acting purely in the y direction? No. Whatever should we do? Trigonometry. No what? Oh man, are you kidding? Okay, so you need to find the components. Okay, don't break out your calculator. You're not doing anything with the numbers yet. Okay, so you're gonna do FTX and FTY. I drew the triangle like that because I gave you this angle in the diagram. Okay, technically, you could draw FTY here as well, and it would be valid. Oops, a little taller. Okay. So with that understanding, go ahead and do step 4. Add up the forces in the x direction and add up the forces in the y direction. Sum of the forces in the x direction, sum of the forces in the y direction. And go ahead and do step 5 while you're at it. I mean, you're right there. Set up what it's equal to. How do we do? Okay, that's your setup. That's what you're doing for homework tonight. Okay. Questions there? Yes, you can have more than one force go in this positive y direction. Okay. Ready for the next one? Okay. Draw a free body diagram of a car parked on a hill on an incline. Draw your arrows long. Draw long arrows for this one. How do we do? Do that. All right. This next part, don't draw this. Okay, don't draw this next part. Just wait for it. That's my x-axis. That's my y-axis. Don't draw this. Okay. How many vectors am I going to have to break up into components? How many vectors don't lie on the axis? 2. Ugh, pain. Okay, check this trick out. Math people hate this. But math is a tool that we can use to describe life. What I'm going to do, grab a hold of this axis. I'm going to tilt it so that my x-axis is now parallel to the ramp. And my y-axis is now perpendicular to the ramp. That doesn't look very perpendicular. Pretend that's perpendicular. Okay? You do that. So you make your x-axis parallel to the ramp. Okay? Now, what's the object? Like, why? Why did I do that? How many vectors now lie off the axis? Just one. Life just got better. Okay? Only tilt the axis when your object is on an incline. Here, we did not tilt the axis. The object is on a horizontal surface. Okay? Yes, something was in an angle, but don't tilt the axis. Only tilt the axis when you're on a hill, an incline, a ramp, slide, anything like that. Good with that? Then you can tilt the axis. Okay? Now, at this point, I'm going to stop saying horizontal and vertical like I did in projectile motion, because the x-axis is no longer horizontal. So I'm going to say, instead of horizontal, I'm always going to say the x direction or the y direction, because the y direction is no longer vertical, it's off at an angle. Okay, you good with that? So step 2 is pick which way you want to be the positive direction. In this case, it's at rest, so it doesn't really matter. So I'm going to make down the ramp the positive x direction and perpendicular to the ramp the positive y direction. Okay, that's step 2. Step 3 is to ask ourselves, is the sum of the forces in the x direction equal to 0? And is the sum of the forces in the y direction, is that equal to 0? Go ahead and answer those in your brain. Hopefully you said equal to 0 in both cases because the object's at rest. Good at that? Okay. Now, which force am I going to have to break up into components? Gravity. Okay. Now, most people don't have a problem with this. Saying this is F, G, Y. Oh, wait a minute. Premature topic. Okay. Apologize. All right. So, the angle of incline. This is the same angle between the new y-axis and the force of gravity. Whatever angle this is the hill. This is the same axis. Sorry, same angle between the y-axis, the new y-axis, and the force of gravity. Okay. There are very few things I'm going to tell you to straight up memorize, but this is one of them. I'll give you the geometric proof. Most people don't care. Okay. Here's the geometric proof. The last time you're going to see this, unless you want me to do it like individually. Okay. You got parallel lines here. The horizon and then the original x-axis. Okay. This angle is congruent to this angle over here. This angle and this angle are also congruent. Okay. This angle and this angle are complementary. They add up to 90. This angle and this angle are also complementary angles, add up to 90. Therefore, this angle and this angle are congruent. So last time, I'm not going to require you to write out that proof. Just know that this angle is the same as between the y-axis and the force of gravity. Okay. Now that's on the table. Most people don't have a problem with saying that this is FGY. Where people run into trouble is I'll give you a choice, and you figure out which one's right and which one's wrong. Is FGX the red? Or is FGX, the dirty green? So ugly. Where the blue would continue on. Can you see the green? FGX. Okay. So think, which one's the right one? Which one's the wrong one? Tell your neighbor and tell them why you think so. Correct answer is red. Okay, here's why. The red is parallel to our new x-axis. Okay, here's why the green is bad. I actually did this in high school. Lost a lot of points. Okay, number one, this no longer is our x-axis. This is. Second reason, your force of gravity needs to be the hypotenuse. Needs to be the longest side to break it up in components. When we do this, this blue side now becomes the hypotenuse, and the component is now the biggest side, longest side, which is like, what? I'm good with that. Like, that's kind of the consequence. Okay. So, correct answer is the red. Okay. So, once we've had that conversation, go ahead and do step 4. Write out all the forces, add up all the forces, the sum of the forces in the x direction. And go ahead and do step 5 too. Set it up what it's equal to. How'd you do? Okay. So your homework tonight is to do day 2 on the free body diagram worksheet. That's what you got.